Hey, let's work a quiz. A golf ball is hit with an initial velocity of 110 feet per second. That number is important. At an inclination of 45 degrees, that number is important. To the horizontal. We can establish that the height of the golf ball is this function right here. First thing I want you to do is I want you to sketch this. And I've given you a suggestion on how you should do your window. Negative 32. Window. I'm going to change my x min to 0, my x max to 400, my y min to 0, my y max to 100. And there's a pretty picture. And I want you to draw that for me. Okay. Second part, determine the height of the golf ball after it has traveled. So what our x is going to represent is how far horizontally the ball has traveled. And what we want to do in finding this the h of the x is figure out how high up it is. So one at a time, I'm going to plug in a 100, a 300, and a 400. And then there's something special or extra about that last one there. So back to my normal screen. And here's how I would do it. 100 gets stored for the x. So negative 32x squared divided by 110 squared plus x. Store 300 for my x. Second enter, bring back that expression. This time it'll put a 300 in place. $400 store for the x. Second entry. Now, the height of the golf ball, this is the answer on the screen. This answer doesn't make any sense. The height of the golf ball is going to be at 0 feet. It has already hit the ground. Okay. Determine the distance that the golf ball has traveled when the height is 80 feet. This is going to be a real proper little equation here. So negative 32. 110 is 121. 110 squared. See? Plus x equals 80. All right, to solve this problem, I'm going to get rid of the fraction. I'm going to go through and multiply everything by 110 squared. And 80 times that. I'm going to take these two numbers over there so that I can get a positive a value, and I'm going to switch everything around. So I'll get a positive 32x squared, a negative 12,100x, and the 96.8 number was already there. Don't change its sign. Quadratic formula, x is equal to a negative b, which will make that positive, plus minus your b squared. Now I'm going to lose the sign because I know if I square a negative or if I square a positive, I get the same exact answer. And all that goes over 2 times our a value, 64. and I'll divide that by 64. Not h is equal to, x is equal to feet. And second enter because I need to do plus and minus. So I'll change this plus here to a minus, enter. Divide that by 64. And you know why I'm getting two answers? Because I'm going to hit 80 feet high when the golf ball goes out and it's on its way up, and when the golf ball is coming back down, and that would be that's that first answer. 114.9367. All right, so it hit 80 feet high. Well, that's an ugly graph. It hit 80 feet high here on its way, and then it hit 80 feet again high when it was farther out on its way back down. That's why you have the two answers. Determine the distance the golf ball has traveled when it hits the ground. Same kind of problem. But now we want to know, let's put a square there. We want to know when it hits 0. This is not as tough as of an equation because you don't have the c value. I still want to get rid of the fraction. So I'm going to multiply by the 110 squared. And I'm gonna just change the signs. I don't like having a negative a value. Now to solve this, I'm going to factor out an x really quick. I could factor more, but the directions weren't to factor, it was just to solve. You're going to get x is equal to 0. It was 0 when the ball was initially on the ground. 32x minus, and then I'll solve this by adding the 110 squared over and dividing it by 32. So the golf ball hits the ground 378.125 feet from where I hit it, or from where the ball was hit. If I was to ask you what is the domain for this problem, these two numbers here would be your domain, and you would encase those with brackets. Have a nice day.